So make sure that you scan. This is the group hemoglobin. Behind is myoglobin. And I'm going to have other ones for the other group later, okay, as the question comes, okay? All right, so pay attention. I have no idea what the question is. And let's see who will raise the hand first, Henry or Emma, okay?
My question is on hemoglobin, and you know, from what I know you study, there are two factors that you study. One of that influence the hemoglobin's binding affinity to oxygen. Can you name them? And number one and number two part of the question is how do they affect the hemoglobin's affinity? Do they increase it? Do they decrease it? Do you know what happened to the BPG in the fetal hemoglobin?
The fetal hemoglobin has less affinity towards BPG than the adult hemoglobin.
Looks like myoglobin won, but I will give a consolation point also for hemoglobin for the hard work. So half of that and full credit there, all right? So let's move on. So the question was what the spike protein do, Marco?
So the spike protein is the protein on the surface of viruses, like for example, COVID, that is the part that invades the cell and hijacks it to use like the structures in the cell to reproduce the virus, basically.
So we came to the conclusion that a spike protein, it binds to an enzyme in the cell, and then that also infects virally all the agents.
Give me an example of a couple amino acids, let's say two that are most likely to form salt bridges.
Okay, so dot here. Wait, so you have the answer there? You have the answer there? Okay, so let's go ahead here.
Okay, so probably the amino acids that are charged. So I know for a fact that histidine, when it's protonated, it forms a salt bridge with aspartic acid. And I guess you said one example?
Yeah.
One example, he gave histidine. He two examples. You had two examples?
Yeah.
Ask it two. He gave histidine. Anyone else?
Okay, so I said aspartic acid and histidine. I can also say glutamic acid and lysine.
Okay, he gave three now, from 1 to 3. So let's go with Marco now. They are still conferring there. Let me go back there very quickly so that they have a decision. Do you trust him or not?
Yeah. Okay, we're gonna go with lysine and glutamic acid.
Lysine and glutamic acid. I like that answer. What about you, Silvia?
Yeah.
Do you like the answer?
Yeah.
And both answers?
Yeah, I like both answers. Good job, guys.
Okay, so we are not going to stay here the whole afternoon. Both groups are going to get full credit. So what question?
So I don't have a particular question on insulin, but if I tell you that people that have diabetes generally have a lower pH, how would you think that it will affect the oxygen in hemoglobin oxygen binding? How you will shift the oxygen binding curve for hemoglobin?
All right, it looks like Manu already have an answer for that question. I'm going to be there in a second. I'm going to switch the camera here. You have to be. All right, so you have an answer here. Chiara gave you the answer.
So, no, she got it. So
Okay,
the
go
curve's
ahead.
gonna shift where?
The curve is going to shift to the right because there's lower affinity for oxygen.
To your right or to Silvia's right?
So
I don't want. I just want to confuse you. Okay, so and your
we said that the curve would shift to the right because there would be a decreased affinity for oxygen.
So let's say that I'm a hiker and I go up, which I usually hike Mount Whitney, which is 14,500. I have good muscles, so I'm not worried about that, but I still need to go and spend about 2 or 3 days before going up high. In terms of hemoglobin and oxygen saturation, so why do you think I need to spend time there before actually attempting to hike. Think of, I'm going up to 14,000, okay? I'm not going up Everest, but those guys will spend a lot more time than me acclimatizing there.
So what, do you have an answer for that question?
So yeah.
Uh,
Go for it.
Okay, so,
At higher elevations, you have less oxygen available. So in result, your body will start producing more BPG.
more BPG is one answer. What is the answer, Matthew? You guys came to a conclusion here yet or no? Yeah? Yeah.
We said that at higher elevations, your body has a decreased affinity for oxygen and it has a higher affinity to bind to BPG.
Generally, the answers are very good. Thank you. Good job, guys.
Okay, so, good job. So we are not going to spend the whole afternoon here. We finish here. Both groups are going to get full credit. And in fairness, the hemoglobin group is going to get their results going to be curved, and they are going to get also full grade. Okay, so everyone got full grade. All right. Yeah. Did you get it? Oh, any questions?
Good luck to you, and hope you guys are choosing biochemistry further down.
Thank you. That was great. I wish all classes were, all sessions were like that, right? Thank you very much. Enjoy the rest of your day. Bye now.